Again, welcome to Research Methods in Computers and Society. This is CS 312 class. In these lectures, we're going to cover different types of sampling. This is our Unit 6 lectures, which cover Chapter 6 of our course textbook. So our main objective is to explain the purpose of sampling, also compare and contrast probability and non-probability sampling. We're also going to describe different types of non-probability sampling and summarize the types of probability sampling. So again, these lectures focus on sampling in a research process. And also we are going to cover both probability and non-probability sampling. Again, the main reason of sampling is because we know when we are doing a research or a studies, we cannot take the whole population data. We cannot collect data from all the populations because that would be a lot of time consuming and also the cost will be very high. So example, we want to do some research work category of adults between the age of 20 to 30 in New York City. Well, New York City may have over 3 to 4 million people with that age category, an adult between 20 to 30. So most likely we are going to take the sampling because it will be a time consuming to collect data from 2 to 3 million people. In this case, we may collect data from only 100 or 200 or even 1,000, but not too much. So sampling is very good, but the process of doing it, we have to be very careful because a population is very good. Population is always a fixed value, constant. We don't calculate any population parameters. The characteristics of population is always true. But when we are taking a sample from a population, we may take 2 or more samples from the same population, but the values may be different. The characteristics may change. So we have to make sure that when we collect a sample, the data is well represented, the whole population, so that when we work on the sampling data or analyze the data, the result we get, we are going to generalize it to the population. So for example, we want to do a study in New York City to find out the average income for adult male between the age of 20 to 40. We have 4 million or 3 million population in New York City with that age category. So we don't want to take all the population data. Again, as we said, time consuming, a lot of money will be involved, the cost will be very high. But this time I'm going to take a sample, but I will make sure that the sample is well represented because the population of 3 million, most likely all the age category between 20 to 40 will make different types of income. Their income will be different. So we want to make sure that we are collecting the data that we are going to remove the bias or reduce the errors in the data. Now, when we take the sample, we may find the average, the first sample, the average should be $40,000 a year. Another sample may say 47,000. Another sample may say 30,000. Now, how can we be sure which one is the correct one? So this is the process of sampling. We have to make sure we are following the right steps to collect the data, and also the data is well representing the whole population. So here we start with some key terms. First, what is a sampling? Sampling is a procedure used to select a subset of the population. So as we said earlier, we have a population of 2 million people. I don't want to collect data from all the 2 million people to take too long. So I may take a sample of only 100, but now I have to make sure that this 100 out of 2 million, the data is well represented, excuse me, the data is well represented the whole population of 2 million. So sampling again is a process of collecting a subset of data from a population. Also, a sample is the subset of the population. So we may have a sample of 100 out of 1,000. Population is 1,000, the sample is 100, so that's a subset of the population. And the population means the entire group of people that the studies focus on. It's everything. So if our studies focus on adult male between the age of 20 to 40, the population means the whole entire group of people that fall within that category in New York City, if our studies is in New York City. Then the last terminology is a sampling frame. The sampling frame, again, is the list of all the entire population under study. So sampling frame is more or less like the population size. So again, we went through the 4 key terms here. Sampling is the process of, again, collecting a subset of the population, then a sample will be the subset of the population. Population is the whole group or the entire group of people that we want to study or focus our study on. Then the sampling frame will be the list of all the entire population under study. Now, the goal again here is to ensure that our sample is representative of the population, which is very, very important. So we want to make sure that, again, because as we said earlier, I'm doing a studies. I want to save the average income of male between the age 20 to 40 in New York City is somewhere around 80,000 or I don't know. So I will collect a sample. The population is 2 million. I collect a sample of only 200. Now I want to make sure that these 200 represent the whole 2 million. Otherwise, I'm not going to get the right data or the right answer. So we have 2 types of sampling: the process of collecting a subset of a population and data. One is the probability and one is the non-probability sampling. So the main distinction between these sampling types is the random selection of participants. The random selection of participants. One of our common process of collecting a sample is using a simple random sample. Simple random sample, which means we join all the group together, we just randomly pick anyone out of the group. So in probability sampling, a sampling frame is used and participants are selected randomly. So the sampling frame will be, in my case, let's say I'm doing my studies, adult between the age 20 to 40, all of them in New York City will be the sampling frame. Then in non-probability sampling, the sample frame is not often available and participants are not selected randomly. So that's the main difference between probability and non-probability sampling. In probability sampling, participants are selected randomly. So again, the difference between probability and non-probability sampling, as we said, again, probability sampling means the participants are randomly selected and also the sampling frame is available. But with non-probability sampling, the participants are not randomly selected and also the sampling frame is not available. So the choice of the sampling strategy, again, depends on the type of studies we are embarked on or we are conducting. So deciding on a sampling strategy, first, there's 4 questions here we have to ask. One is your study qualitative or quantitative? What is your question of interest? And also, is your population easily accessible? And also, is your topic sensitive? So these are the 4 questions. Based on these 4 questions, we may know, again, what type of sampling strategy we should use, whether probability or non-probability. Now, within the probability, we have different types of sampling again. For example would be simple random sampling means the male or the female are all together. Now, what if I want to do a study and I want to get exactly 10 male and exactly 10 female? This means I can't do simple random sampling. I cannot combine the male and female and just randomly select. Otherwise, I may select either more or less male or female. So this type of sampling is called the cluster sampling. I will cluster the data into group two groups, male and female. I'll randomly select 10 from male and then 10 from female. So again, deciding on the type of sampling strategy, I would say it 100% depends on your type of studies you are doing, the type of data you want to use. So we start with the non-probability sampling. And we said in this type of sampling, some people have a higher chance of being selected for the study than others because this is non-probability. They don't have equal chance. Randomly selecting a person, we have 100 people. Randomly selecting one person, all the 100 people have equal chance, 1 by 100 chance of being selected. So with non-probability, there's a cheating. Some people may have a higher chance of being selected, maybe based on some criteria, and some people may have a lower chance of being selected. But with probability sampling, everybody have equal chance of being selected. So the focus on population that are harder to reach or where sampling frame does not exist, that's the best method of using non-probability sampling. We don't have the sample frame, and also the focus on population that is very hard to reach. So we use, again, non-probability. This type of sampling, it's very hard to generalize the findings, excuse me, to the larger population. Why? Because here we may collect a sample, but this sample is not well representing the whole population because some have a chance of being selected, some have a chance of not being selected, or higher chance of being selected and lower chance. So there's no fair ground on this non-probability sampling. So the sample we are going to get will not be well representing the population. Also, in this type of sampling, researchers select any particular person or any participant who is really available to participate in the study. Example would be people in your network, people in your classroom. We don't care about generalizing the whole population here. It's against non-probability. I would rather prefer to use my family members or my friends in my studies than to go to the field randomly selecting participants. Also, their participation happens based on availability or accident. And also, this type of sampling can be cost and time effective in the case of pilot studies. That is a study that represents initial inquiries. So here we talk about the convenience sampling will be a good example. So example of a non-probability sampling will be convenience sampling. So here we have a population, and then we conveniently again select anyone we feel is convenient for us to select. So there's no any criteria, we just pick the one that's, so this is again non-probability, convenience sample, based on conveniency of the researcher or the investigator. So non-probability sample, also we have the snowball sampling. In snowball sampling, participants normally are selected by word of mouth, So the sample may not be representative of the population, as participants know each other in the same way and may also share characteristics such as social class, income, or religion. They may be family members, they may be friends or classmates, etc. If using this strategy, it's very important that we gain participants' trust and protect participants from harm. Also, the benefit to this strategy include its usefulness in identify hard to reach population. For example, drug traffickers. If I want to do studies on this, it will be difficult to reach them. But again, if you know them, then maybe it will be more easy to reach them. So this is a word of mouth. We have the population, and basically again, friends or relatives, co-workers, From the word of mouth of each other, we may again select our sample. And again, it's called a snowball sampling. The next non-probability sampling is the purposive sampling. Purposive sampling. So this is also known as judgmental sampling. Here, the technique by which the researcher targets the sampling to a very specific population with unique characteristics. Example can be, let's say, children who were homeschooled. Also, the homogeneous sampling is a type of purposive sampling where participants are chosen based on a trait or a characteristic. Deviate case sampling is when the sampling focuses on unusual or very specific cases. Example would be high school dropouts. So that's why we call deviate case, unusual cases. So this is an example of a purposive sampling. Again, we have our population, and we again select based on the criteria. The next of non-probability sampling will be the quota sampling. The quota sampling, again, is a technique that allows the comparison of different groups within a population of interest. So here we say in proportional quota sampling, the sample is representative because we have a quota, we have a percentage of the category that we are dealing with. So the sample is representative in the same proportion of the entire population of interest. Also in non-proportional quota sampling, the sample uses a different quota from one found in the population of interest. So this is an example of, again, proportional quota sampling. Yeah, we have the population divided into 4 different sections, and we decided to select two from each group. Or here we may decided to select 2 or 1 from other groups. And this is, the previous one is proportional, the same amount from each group of the population. Here is non-proportional. We have 3 and 2 from another group, 1 from another group. Now, things to consider when selecting a non-probability sample. First, we talk about the cost. It's a very cost-effective and easy to accomplish, not too expensive. And also, it's very excellent for exploratory studies. But as we said, the data always will not be well represented. So it's difficult to generalize the result of the sample to the population. So next we start with the probability sampling. Here we have the simple random sampling, which is the most common and most easy. So simple random sampling means we have the category of the population, let's say adult between the ages 20 to 40, 1 million, all of them together in one place. We will randomly select any amount we want. So probability sampling, one of the main rules is that everybody have the fair chance of being selected because it's random. Randomly we pick. So simple random sampling means the population is 1 altogether, we randomly select. Now stratified random sampling means we are going to select based on our status. It's kind of like cluster also. So we have some condition that we are going to specify. Based on that condition we select. Systematic random sampling can be based on a period of time. Let's say I want to collect a sample in a subway station, and I was told that every 10 seconds I'll collect 1 data, a sample. So this is systematic. It's based on every 10 seconds or every 10 minutes. Then we have a multi-stage sampling. So first, again, simple random sampling. Here we say the sampling procedure that relies on complete randomization without any boundaries. Here what we mean is that we have one big population. All the population have equal chance of being selected. So we are not going to divide the population into 2 or more based on any category. It's one population. So that's why we said it's a sampling procedure that relies on complete Again, complete randomization without any boundary. Also, it's very appropriate when we know the population we intend to investigate. The example will be a list of population is available in a phone book. Also, we need to conduct using random number generator. It can be conducted using random number generator. So picking numbers or participants from a fishbowl or other simple techniques. Also, advantage are that every member has an equal chance of participating, and also to ensure representation of the population. So this is an example. We have a whole population, then we randomly or simple random sample means we randomly select any amount we want. There's no any criteria based on it or anything. We randomly select. So next we move to the stratified random sampling. This is a sampling procedure that is appropriate when we are focusing on understanding, comparing, and also analyzing different groups of a population. And also it requires equal numbers of participants from each group, men and women or different ethnicities or the marital status. The list of different groups are called a strata. So stratified random sample, as I said, a very simple example. I want to do a research. This research, I need exactly 20 male and 20 female. Now, if I do simple random sampling, I may end up selecting 40 male without a female, or 40 female because all the male and female have equal chance of selecting. So if we have about 3,000 male and 3,000 female, there can be a chance that if we're doing simple random sampling, we are going to select all male or all female, or maybe only 20% male, the rest 80% female. So the best way to do this is to use a stratified random sampling. I'm going to divide the population into two. We have the male and female, and I need 20 for male and then 20 for female. So here we say it's a sample procedure that is appropriate when we are focused on understanding and also doing comparing, analyzing different groups. Here our groups is male and female. So it requires equal number of participants from each group. And also the list of different groups are called a strata. So next is the proportionate and also disproportionate stratified sampling. So proportionate stratified sample means a procedure that are equivalent to the proportion of the population. They are equivalent to the proportions of the population, but it will create specific strata that are of interest to the study. The second disproportionate stratified sampling, the procedure that are not equivalent, that's why it's disproportionate, not equivalent to the proportions of the population, but it can create specific strata that are of interest to the study. So this is an example of proportionate stratified sampling. We have exactly 3 from each categories of 4. Then disproportionate stratified sampling. The first one we have 1, second we have 1, third we have 3, fourth we have 4. So it's not the same amount, it's disproportionate. So next we go to the cluster random sampling. This is a very common technique also. It's a technique of sampling that allows the researcher to create separate random clusters first, then randomly select participants from each cluster. So a cluster can be a group of population within which the participants are going to be randomly selected, and the clusters may have a condition, maybe male and female, or participants who earn more than $80,000 a year, cluster A, less than $80,000 a year or equal to $80,000 with cluster B. So a cluster will be a group of population within which the participants are going to be randomly selected. And clusters need to be as similar to the entire population as possible. Then we have the systematic random sampling. This technique can be based on selecting the nth number on the sampling frame. So n will be the sampling interval or ratio between sampling frame and the sampling size. So this is an example of I want to take a sample data from a supermarket, and I can say that every 10 minutes I'm going to randomly select one person to ask any question. So this will be systematic random sampling because it's based on time interval, and we collect this data, and it's every 10 minutes. Then also we have the multi-stage sampling. In a multi-stage sampling, the keyword is multi. We have 2 or more stages. It's a sampling technique based on the combination of 2 or more types of sampling together to best suit a specific study. And things to consider when selecting the probability sampling. Again, the study will likely be costly, the labor or time. Also excellent for conducting larger studies and not always appropriate for exploratory studies. Also, the questions need to be well thought out, as going back to the participants is not possible. And also easier to utilize if you have already completed a study in the past. So this will be our conclusion for sampling. Again, in this unit 6, which cover chapter 6 of our course textbook, we discuss about different types of sampling. We said there are 2 major types of sampling, the probability and non-probability. Probability will be the best one and is the most common one we use to collect our data, because in probability, all the participants have a fair chance to be selected and the data is well represented, representing the population, which is, I think, the most important part. Because after we analyze the data, we have the result we get, we are going to generalize it to the whole population. So we have to make sure that the sample we collect is well representing the population. There's no bias. Then from there, we study different types of non-probability, such as convenience sampling. Then we also word of mouth sampling, which is based on recommendation from friends or relatives, co-workers, etc. Then we went to the probability. In the probability sampling, most computer statistics cover this topic in probability sampling. We have cluster, simple random sampling. We have stratified sampling, multi-stage sampling. Multi-stage sampling means we can combine 2 samplings types to again perform. So that will be the end for Unit 6. Again, Unit 6 cover the topic of sampling. So again, wish you the best and thank you.